In this video, we'll solve trigonometric integrals. So let's take a look at the first integral. Integral of sine squared of x dx. Well, in order to be proficient at this chapter or this topic, you need to know trigonometric formulas very well. So we know that cosine of 2x is 1 minus 2 sine squared of x, the double angles. So 2 sine squared of x is equal to 1 minus cosine of 2x, or sine squared of x is equal to 1 over 2 minus 1 over 2 cosine of 2x. So I'm going to use that in this integral that we are calculating here. So that's integral of 1 over 2 minus 1 over 2 cosine of 2x dx. We separate in two integrals and we get 1 over 2 integral. So when we calculate this one, it's just integral of dx, so that's x, minus 1 over 2 integral of cosine of 2x, it's sine of 2x over 2, plus c because it's an indefinite integral, so 1 over 2x minus sine of 2x over 4 plus c. This would be the answer. Let's take a look at another problem. Integral of sine to the fifth of x dx. Well, in this case, when we have odd powers of sine or cosine, we're going to write sine to the fourth of x times sine of x dx. Now, sine to the fourth of x can be written sine to the squared of x, everything squared. Sine to the second, it's 1 minus cosine squared of x, using the Pythagorean identity, sine squared plus cosine squared of x is equal to 1. So now if we introduce this back into the integral, we get integral of 1 minus cosine squared of x squared times sine of x dx. So if we use the substitution u equals sine of x with the differentials du equals cosine of x dx. Oh, sorry. Well, it's a good problem to actually see. Well, if we do that, cosine of x dx, we don't have that. We actually have sine of x dx. So the correct substitution would have been u equals cosine of x. I got carried away. Actually, u, it's that interior function, and so here, if we take a look, this would be the problem that we have to solve the integral. So du is negative sine of x dx, which means sine of x dx is negative du. So this quantity here, sine of x dx, it's exactly what we found here is negative du. So if we plug in here, we get integral of, so the blue one is negative du, I'm going to put the negative in du, and then 1 minus cosine of x is u, so minus u squared, everything squared. So this integral is negative. I'm going to open up the parentheses, so it's 1 minus 2u squared plus u to the fourth du, and we are going to use power rule to evaluate each of them. So, and I also have this negative, so it's negative u plus 2u to the third over 3 minus u to the fifth over 5 plus c. So in our case, u is cosine, so it's negative cosine of x plus 2 over 3 cosine to the third of x minus 1 over 5 cosine to the fifth of x plus c. Let's take a look at another problem. This one is a definite integral. Integral from 0 to square root of pi over 2 of 2x sine to the third of x squared dx. So let's try u equals x squared. Let's use that substitution. So I took a look at this function. I saw that x squared is the argument of sine, and I'm thinking that x squared prime is 2x, so there might be a connection there. So du is 2x dx. So this integral is going to be integral of, so this 2x dx, I'm going to replace it with du, and then sine to the third of u. Now the limits of integration are for x only, so I'm going to use them only at the very end when I plug in x. So this time we're going to solve this problem using sine squared of u times sine of u du, like we did with the previous problem. Sine squared, we write it 1 minus cosine squared of u times sine of u du. And we use again a substitution. Let's say w equals cosine of u, dw equals negative sine of u du. So we get integral of, so sine of u du is this piece, so is negative dw. So negative dw and 1 minus w squared. So we get negative w plus w to the third over 3 plus c. So now let's go back into each substitution. So negative w is negative cosine of u plus cosine to the third of u over 3 plus c. And I'll replace back the u with x. So it's minus cosine of x squared plus cosine to the third of x squared over 3 plus c. Now, let's not forget, I wrote plus c because I got carried away. I forgot that this is a definite integral. So there is no c, because the c, it's actually, if we substitute square root of pi over 2, it's going to still be c, minus if we substitute 0, it's going to be c, c minus c is 0. But we have to evaluate this from 0 to square root of pi over 2, and then from 0 to square root of pi over 2. So then we get negative cosine of pi over 2 plus cosine of 0 plus cosine to the third of pi over 2 over 3 minus cosine to the third of 0 over 3. So if we compute this, we end up with cosine of pi over 2 is 0. So we get cosine of 0 is 1. Cosine of pi over 2 again is 0. So minus 1 over 3. So we get 2/3. Let's solve another problem. Integral from pi over 6 to pi over 2 of dy over sine of y. Now in this case, if we put 1 here, and that's no problem, we get integral from pi over 6 to pi over 2 of cosecant of y dy. Now this type of problems, where we have cosecant of y or secant y or x, this is what we do. Let's put the dy all the way here and multiply by cotangent of y plus cosecant y over cotangent y plus cosecant y. So if we do that, this is what we end up getting. Integral from pi over 6 to pi over 2, cosecant y cotangent y plus cosecant squared y over cotangent y plus cosecant y dy. And why did we do that? Because if we set u equals cotangent y plus cosecant y, du, it's actually given by, well, cotangent of y prime is, what would that be? Well, cosine y over sine y prime plus cosecant y over sine y prime dy. Well, this one is going to give us, if I use quotient rule, cosine prime times sine prime is negative sine squared prime minus cosine squared y over sine squared y, and then minus cosine y over sine squared y dy. Well, if we do compute this, at the numerator here I get negative 1 over sine squared of y. Well, that would be cosecant squared of y with minus. And this one minus, if we split it in sine y times sine y, I get cotangent y times cosecant y dy. So just take a look at the numerator. This numerator, dy, it's exactly this du with minus, because all these are positive, are negative here. So it's going to be integral of du over u, let's put a minus, and this gives us negative ln of absolute value of u which is equal to, I'm going to continue it here, negative ln of cotangent y plus cosecant y from pi over 6 to pi over 2. So all we have to do is plug this in and see what we get. So if we plug in the top one first and then minus the bottom one, and I have minus here, that's why I have plus. So we get negative ln of cotangent of pi over 2 is 0, cosecant of pi over 2 is 1, plus ln of cotangent of pi over 6 is square root of 3, plus cosecant of pi over 6 is 2. So we get this, it's 0, we get ln of square root of 3 plus 2. I don't need to put absolute value anymore because square root of 3 plus 2 is positive. Solve integral of sine of 3x cosine of 7x dx. In order to solve this one, we need to know some trigonometric formulas like sine of p times cosine q, which is equal to 1 over 2 sine p plus q minus, plus sine p minus q. So in our case, p is 3x and q is 7x. So if we replace, we get 1 over 2, I can write it outside, sine of 10x dx plus 1 over 2 integral of sine of 3x minus 7x, which is negative 4x dx. So we get 1 over 2 integral of sine of 10x, it's negative cosine of 10x over 10. Sine, it's an odd function, so that means this negative comes in front, so minus 1 over 2. And then integral of sine of 4x is negative cosine of 4x over 4. So we can compute this and get negative cosine of 10x over 20 plus cosine of 4x over 8 plus c. And a quick hint for this problem, integral of sine of 5x times sine of 7x dx, you can use this trigonometric formula where p is 5x and q is 7x. I hope this helps.